Hello, welcome to CADinBIM, where we train civil and structural engineers. My name is Lucas Muronge and I'm a civil engineer by profession. In this tutorial, I'm going to guide you through on how to design the building you are seeing on my screen. This is a G+12 building. I'm going to do everything, including this pad foundation. So if you are interested in really learning ProtaStructure in the right way and from a professional who really understands structural design, then this is the best opportunity. Ensure you like, you subscribe if you haven't already, then you watch to the end. Leave a comment and tell me what you really need me to teach in my subsequent videos. So having said that, let's just take you through on how I've broken down my sessions so that you at least have a glance of the order in which you are going to learn. So this is a G+12 building. As you can see here is a high-rise building. So we're going to apply things like window loads. We're also going to do things like seismic application. We're going to design not pad foundation for this case, but beam raft foundation. Or we can also shed light on how you can do a slab raft foundation in the same case. So here are just the steps that I can show you. So the first step will be importing a general arrangement drawing from AutoCAD to ProtaStructure for modeling, and then we do set project parameters. We set project parameters, we create structural grid and levels, we do modeling of structural elements. As you can see on my screen here, all these are the steps. I simply don't want to read word by word, but for the interest of time, let's go get started. So this is the model that I had already modeled. As you can see here, these are the lift areas, and as you can see, let me just modify this. So this is the lift area, as you can see here. This is the staircase area, and then this is how the structure looks in structure analysis. This is the architectural plan that we are basing our this is the architectural plan that we are basing our structural design on. These are typical floor, as you can see, ground floor, and it's typical up to G+12. So let me show you another thing. So this is the GA drawing that I've just prepared in AutoCAD. You can see how I have arranged my beams. As you can see, they are here. The grids, this is the grid lines from AutoCAD. This is the column layer, and this is the beam layout. So that's what I have prepared. Then here's the analysis that I already did. You can see the beam raft foundation. This is a well analyzed model that's showing that my building design passed the design code. And we also have this just the distribution of displacement or moments in the raft foundation. Then what else should I just be showing you? This is just the model that I did, which I have already shown you. And if we come here, we have what is called, before I show you the design code, we have here the steps further broken into so I'm just showing you so that you actually understand what you want to do. You can see here are the steps that you are for the workflow, but I've further broken the steps into smaller, into a more subdivided version that we will be using, like have analysis. I have to trace the first image. Oh, I think here it is. Let's just put it here aside and we read it through. Yes, this is the first step, like importing what should be done. So you can see that actually what I'm doing, it's well structured and it's going to be very educative. Let me just zoom it for you if you really need just to read through. Here it is. Yes. For the interest of time, I don't want to read word by word, but I'm just showing you all what it will take us to do that design correctly. And after that, that's step 7. We have your step 8. I'm just zooming so that you can maybe pause a little bit and read through so that you understand. These are all the steps that are needed to do that model. So having shown you that, the last thing I want to show you here is our loading and loading and material selections. As you can see here, this is the client, you can say, is the CADinBIM Masterclass. And then we have the region is based in Nairobi, Kenya. This is a residential building. We are basing our design in BS 8110. Concrete, steel, all these are the parameters that we are going to use in our design. So it's easier that when we are keying into the software, things that we already calculated, or the parameters that we already know and actually are conversant with. Now, having just taken you through all that, let's now jump back into the software and start our analysis. And to start our analysis, what we usually do, we just come to new and we just say create a new project. We just give it the project a new name. You can just say like this, maybe this is a G+12. Then you can say maybe this is 001. 001. Let's just give it like that. Choose your building code, maybe BS code, and then just click OK. So once it open, the first thing that you do once you land into ProtaStructure like this, the first thing that you do is just to import that GA drawing, general arrangement drawing from that you have prepared in AutoCAD. So to do it, you simply come to DXF file import, just click under BIM. Under BIM here, under this BIM, you can just get this DXF file format, or you can also get it from building setout. And we have it here, DXF import. So just click there and then come here to DXF format import. And then this is the file that I'm looking for. Just click on it. Once it comes, you can now choose the grid. You can also choose the column. You can uncheck the beams, but for our case, let's just check it. And then we just import here. You can just uncheck these, but will give us hard time in just import to just save us our time. So once you import our structure, this is how it will come. And now that you have imported our structure, the first step that you want to do is actually to do the grid. So that's why I actually prepared this. So once you import your architectural drawing, I'm just doing this for memorizing. You know, we want to master these steps. So the first thing is that you have to clean the AutoCAD drawing. That's to clean the layer, organize unit, check necessary details, and remove the unnecessary. So want to do cleanup of our model so that it looks clean. And mostly in ProtaStructure, what we are going to do here is basically to clean like this unused grids. And maybe to be quick, you can just come to review, and then you can say delete unused axis. There are around 16. Just say yes and just try to delete them. Delete unused 16, delete. I think those have gone. And now just come to these ones, try to delete these ones, because we don't have, I don't think we have a grids like this. So this is the first thing that you want to do here. I'll just be faster. At some time I'll pause and speed up my analysis. I'll just pause and speed up my drawing so that I don't take, this video doesn't take too long. Sorry. Maybe if you have something that you really need to understand as far as ProtaStructure is concerned, kindly be free, leave a text. And here we have, and you can see some of these grids look so close and we really didn't need them. Remember that in our G+8 we had done our grids, all our grids were known. So what we can do here, we can simply select all these grids. Simply, or we can simply come to grids here. Let's just come to axis. Here in ProtaStructure, they refer to grid, or you can simply come here and try to delete. You know that our grids are labeled 1, 2. That you can simply delete this if it would be possible. Delete the grids. Don't need these grids here. Just select the first one and hold the shift button to select all of them. Just say delete. You can see they are just failing to delete. So if they are failing to delete, you can simply come to select all the grids. Then right click, let's go to table. Under table, click axis table. Under this axis table, you can see all grids that we didn't name previously. We can just hide them. So we can start from this grid here. Start by hiding this grid. This is 1, 2, 3, 4, 5. So I'm just hiding my grids that I know these are the grids that are not required, because before I did an import into ProtaStructure, I already named all my grids. So I have all those grids there. And let me just check. And another thing that you can do is simply to remove this. And where you have clicked, you can simply select this and now just choose remove the marks. Just remove. I'll just show you what I'm just trying to do. I'm just cleaning up my model. Remember, so as you can see, there are this grid that I've hidden here, and I don't think we really needed them. And if need be, we'll simply click like that, right click, we open up the properties. We can just, instead of hiding, we can unhide maybe a grid like this, and we'll have it back there. If you want to get the icons back, you simply click like that, and you simply click here. Yeah, you can just click like this and hide, then click there, update. If you simply feel that there is any grid that ought to be returned or be taken back. So I was just trying to clean up my model. So as you can see, I have all my model well arranged here. Like you can see, this is 1, 2, 3. So I have another P here. So there is another grid that should be introduced. If you see that's a significant grid, just do this, go to properties. You can always edit them here. But now just give it like 2 prime or just 3 prime. Click enter and update. Another thing that you can do here, this one you can simply right click it and name it to grid 15. Go to property, and instead of 15 just name it 16, and then update. Yes, so having done all that, you also check your grids below here, this A, B, C, D, E. So we have this one, so you can name this one as D prime, just for consistency, so that you know which member is closer to each grid. Now, if you leave it at 1C16, it will kind of confuse you, because we really need these grids to position our structural members correctly and accurately. So D, E, F, G, H, we have 2 H here. So we can call one H prime. Let me see. Why do we have H here? Okay, we can call one H prime and one H. Now, if you have 2 grids, then you obviously get some errors when you're running. So do not go through to ensure that you don't name them the same. So do that, come and say H prime, update, close. Do you have any other member? Just check. So we have all our grids well set. So I think we are done with the first step. So the next step will be actually doing now the modeling of these the modeling of our beams. So to do that quickly, we simply come back to our drawing here and we try to locate how our model looks like. This is how model looks like. So maybe we could just put side by side this model versus our so you can put side by side so that you always have an easy time in modeling. So let's just do it very fast. So we have this model here. So just click on beam, right click. So we want just to do our beams. So you can dock this one somewhere there. Then we just clone like that. Under which you can just do this. You can also do this. We have another beam here. You can simply close this. Simply come up to here and then just close it with here. So just go quickly. Just undo that. Once you before that, you have just to do the main column here. This is like our main column. After doing a main column, we just come to this one here. You can just undo it. Just right click on the column, go to properties to activate the column command. Just bring it there. Come here and see it's not very vertical. So just delete it and simply just right click, go to properties. So we have to be very careful so that we just snap it. So this is how you do, you draw the grid. So I'm speed up and just try to finish up so that we just continue so that the video doesn't take too long. But I hope you just understand the concept. also close here with a beam. Simply also come here and also close here with a beam. Also come on this side. Maybe if you see this beam a bit longer, you can simply close that with a beam. Yes. Maybe if you see that's being a longer one, just close it with a beam. Just say yes. With that, we are now done with our modeling. So the next thing that we'll be doing is adding a staircase here in this region. Let's just confirm that's the position of the correct position of our staircase. As you can see, really, let's just go to the other model. Yes, this is the position of our staircase, as you see lift being on the sides, as you can see. So this is our staircase here. So let's go back. So this is the region for our staircase. So Prota 2026 gives the option of modeling our staircase correctly. Just come to under staircase, just pick insert region, click. You must do load analysis. You can do that. Just say yes. Come to load generator. Just generate the vertical window. Just click OK. Yeah, you don't want to mind about the settings. We'll do other load combinations. So once you are there, just come to these parts, just click, and the staircase opens, and we have this type of staircase. Simply come and click here, come all the way to here. We have our staircase here, you can see it. So one thing that you have to do is that let's change the thickness of our slab to 150. Enter. Then you also change the waist of the staircase to 150. Then now you come and apply your loading. So here you can say this is just like a room, the weight of a room on the staircase. And another thing here, you can give it, this is just load library. You can choose the general domestic building as I had indicated, then just click OK. Now we have our staircase there ready. So having done that, we can actually now check our model before we add our slabs. So to check our model, we simply come to building analysis, go to building analysis, come to analysis, check building analysis. You should be checking frequently your model so that you see if the errors that we are seeing can easily be managed before we move so far. So what we are getting is these beams. So we have beam are overlapping, axis 1 at 2 are overlapping at this distance, have axis overlapping, and then we have, so we have the issues with the axis. So operation complete, the rectify warning. Okay, so we can simply click on delete. No, just say okay, just close. Let's see this unused axis here. Don't think we need this axis here, just click it, right click, delete, say yeah, okay. C13, C123, we have to delete that one first. C123, this is C22, C21, C31, C27, C123. Okay, so it's the, just delete this, and you can now delete that axis easily. So just come here, come to properties, and there you have it. That you can simply replace here. Okay, I've done this one wrongly, so So for the axis, some axes were hidden, but it seems that they were overlapping with what we already had. So we can just assume that error and we proceed to slab analysis. So to do our slab, you simply come to modeling, just come pick the slab, define your parameters for the slab. We need a slab of 150. And our loads, this is self weight is 3 point that. You can remember we had defined some of our loadings. So before we started, I did definition of our parameter, design parameter, and you can see these were the design parameter that we had opted for. So having this in mind, you can go back and actually define the load for the slab. Here we have a dead load of 1.5, under which we have an imposed load. You can simply click this, pick it from the design library based on the code you are using. Might be different based on the code you are using. For us, we're using BS8110, and if you're using any code that is not BS8110, you can get a different value, which is acceptable. Maybe we can leave it at 25, then just give it enter, just pick BIM region. With that, having said that, just update. You can simply come and continue putting your slabs. So maybe if you want to work side by side as you see what you are doing, you can always activate the view windows to 2. Just come here, come to view windows, right click, come change, just go to view, right click, go to 3D modeling. So once you create an extra window, you just come to view, under view, go to vertical. So we have here 3D view. So we can always see what we have here and we can relate it. So let's simply check on that. Go to property, go to properties, you can dock it maybe somewhere here. For those areas that are not enclosing properly, you can just redo them later. I think this panel is too long. We need to just introduce a beam in case it fails. Yes, we are almost done with the slabs. So these regions that had funny slab, just delete them. Simply want to delete the slab itself, just come here, pick this, right click, properties. Under properties, simply come to fix. Under properties, just come and change here from beam region to pick points. Under pick points, you simply come here, Yes, I think now we are done with our slabs. We don't have any other slabs. So having done the slabs, let's just come here. Change this one from reverse to, oh, we did it the wrong way. Model river, just click on this, come to axis, right click, come to physical analysis model, under which we have it here now. You can actually see it like that. You can see the staircase here. So with that being done, that you can actually refer back to our design procedure so that we are able to know what to cover systematically. So remember that so far what we have been able to do, we have been able to do step 1, I've done step 2, we have already done step 3. By just selecting our code, we have also done step 4. We have done, so we are here in step 5. We have done columns, we have done beams. So we are now working on shear wall. We have already done, we are now doing slabs. Under slabs, we have these normal slabs, and also we're having some cantilevers. So let's proceed and do cantilever. So to do cantilevers, we have a cantilever here, we have another cantilever there. So to do that, simply come to modeling. Under modeling, just choose slab. Under slab, choose the cantilever type of slab, which is slab number 12. Give it appropriate depth. Go to loads. Under loads, you can give it 1.5. Then you can also leave this one to general residential building. Under cantilever here, you give it a load of maybe 1 kilonewton, then add a cantilever of around 1500. Let's just try that. Then we also have these as let's just say not 1500, that should be, you can give it first 1500. Then what else do we need? I think those are sufficient. Just click here, say update, and now pick points. Just come and pick this part here, pick this part here, and now pick this part here. Yes, we have our, you can see now we can also proceed with that slab. Also, that slab should also be put here, that cantilever slab, and finally just come click there. We also have this, just come pick here, come pick here, and now just pick on top there. We also have that cantilever slab. We also have another cantilever slab here. Pick that, and pick it here. We also have that cantilever slab. So we also need another cantilever slab here. That slide, let me just show you from what we just did. As you can see, we have a cantilever slab here, which is a balcony. These are a large balcony. This is also a balcony. And we also introduce, our beams just came here. We also need another small slab, another small cantilever slab. So to do that, we simply come here and let's just offset to 1000. Just come to this. Cannot find a common axis for element insertion. Okay. So we have it there. Just right click, or instead of right clicking, just come here and now go back to cantilever and change this height from 15,000 to 1000, 1500 to 1000, and just click update. Yes, so you can do same for these other parts. Simply click here just begin list, snap that part and just snap one on top. You can see we have that cantilever. You can also do that very easily. Then we'll be done with our slabs. And also we have this one here. Now just edit this one. Just right click, go to properties. Under properties, just simply come and change this one from that to just 500. Just click enter, update. Okay, that cantilever should be 500. Enter, update. Yes, that one. Now we are just almost finishing modeling our cantilevers. You can just come here. So we have our cantilever.